good. So solving simultaneous equations where you have one linear and one nonlinear equation. In this question, number one, y is equal to 2x squared plus 5x minus 3, and then y is equal to x plus 27, right? So let's call the first equation 1, and let's call the second equation 2. Which of these equations is linear, guys? 1 or 2?
2.
Yes. Y is 2 linear? Kaylin, it is linear. That's correct. 2 is the linear equation. But why did you say that 2 is the linear equation? Why is that?
Okay, because I learned that anything that looks like that is linear, and also if you were to plot it on a graph, it would be like a straight line.
I mean, that's solid for sure. It is. If you plot the second equation, y is equal to x plus 27 on a graph, it will be a straight line. That is correct. But the way to spot a linear equation is the highest power of x would be 1, right? So the highest power of x in this equation here is 1. It means this is a linear equation. In equation 1, right, the highest power of x here is 2. That makes this equation, what type of equation is equation 1? Anybody knows? What do we call this equation? 2x squared plus 5x minus 3. What kind of equation is that? Where
A
the highest power.
quadratic.
Correct. It's a quadratic equation, right? So equation 1 is a quadratic equation because the highest power of x is 2. And equation 2 is a linear equation. The highest power of x is 1. And on a graph, the first equation there, y is equal to 2x squared plus 5x minus 3, that quadratic, would be a curve. However, the second equation, which is a linear equation, it'll be a straight line, right? Now, all along, when you've done simultaneous equations before, you've only worked with linear equations, but you can also find the solution to a pair of simultaneous equations when one is not linear and the other one is, right? Just like with simultaneous equations, if you have two linear equations, the solution is basically the point of intersection of the two equations, right? The graphs of the two equations. So you can solve simultaneous equations either algebraically, which we're going to do now, and you can also solve it on a graph. The graph of a pair of simultaneous equations, they'll intersect at a point, and this point would be your solution for x and y, where the coordinates, the x coordinates will be the value of x that you solve for, and y would be the y coordinate that you solve for, right? So in the case of this one, which is a quadratic, well, it might be something like this, right? Where this is the straight line. So this would be equation 2 here. And the curve is equation 1. So both of them, the curve and the line would intersect at 2 points instead. And that's why most times when you solve a pair of simultaneous equations in which one is linear and one is quadratic, you get two solutions for x and two solutions for y. It's because you'll have you may have 2 points of intersections, right? Points of intersection, sorry. So that's basically some things to note. All right. So let's solve the equation. Now, as you can see, equation 1, it's y is equal to 2x squared plus 5x minus 3. And then in equation 2, it's y is equal to x plus 27. Now, both of these equations are equal to y. And since they are both equal to y, what we can do is we can equate the equations, meaning that if they're both equal to y, then you can say that whatever equation 1 is equal to, which is 2x squared plus 5x minus 3, that would be equal to equation 2, which is x plus 27. So most times, if you have it like this, where it's y is equal to something, and then y is equal to something for both equations, you can equate the equations. Because if they're both equal to y, it means they're both equal to each other, right? So that's the first step. We equate equation 1 and 2 simply by writing out what equation 1 is, 2x squared plus 5x minus 3 equal to x plus 27, because they're both equal to y. All right. Now, when we simplify this equation, or we bring all the terms to one side of the equation, you're going to have a quadratic equation. You can already tell that this is a quadratic equation because the highest power of x here is 2, right? So what I'm going to do next is I'm going to move all the terms from the right-hand side to the left-hand side. So this will become 2x squared plus 5x minus 3 minus x. Now, if I move x from the from the right-hand side to the left-hand side, it'll become minus x because it's a positive x on this side. And then my plus 27 moved to the transposed or moved to the left-hand side will become minus 27. And all of that is equal to 0. And now I'm going to simplify the quadratic. So this will be 2x squared. I'm going to group my like terms, right? So 5x. Here I'm going to say 5x, take away x, which will give me plus 4x. And then I'm going to say negative 3 or minus 3 minus 27, which will give me minus 30, right? Minus 3 minus 27 is minus 30. So now I have this quadratic that's 2x squared plus 4x minus 30 is equal to 0. Remember, once it's a quadratic that you're working with, in order to solve a quadratic, it has to be equal to 0, right? So 2x squared plus 4x minus 30 is equal to 0. Now, I am going to divide throughout by 2 because all of these terms are divisible by 2, and I much prefer to work with smaller numbers. So dividing throughout by 2, and I'm writing that in so you know what I did. Right, so dividing throughout by 2, since that's the highest common factor, all of 2 can go into each of these terms. That would give me, well, 2x squared divided by 2 is just x squared. 4x divided by 2 is 2x, and 30 divided by 2 is 15. So now I have, and well, of course, 0 divided by 2 is 0. So now I have x squared plus 2x minus 15 is equal to 0. And guys, at this point, you can solve this quadratic by using any one of the methods that you know. That is completing the square, factorizing, or using the quadratic formula. I am going to factorize it because I'm clearly seeing that the factors here would be 5 and 3, because 5 take away 3 will give me positive 2, and then 5 times 5 times negative 3 will give me negative 15. So this quadratic can then be written as x plus 5 by x minus 3. All of that is equal to 0. And I don't know if you all remember, but if x plus 5 and times x minus 3 is equal to 0, it means either x plus 5 is going to be equal to 0, or x minus 3 is going to be equal to 0. We did so much of this before, but I know it's not a topic that some of you have done in school, so you may have forgotten a little bit of it. Don't worry about it. All right, so then if x plus 5 is equal to 0, that means x is equal to 0 take away 5, which is negative 5, or x minus 3 is equal to 0, so then x is equal to 0 plus 3, which is 3. So that's your two solutions for x. Either x is equal to 3 or x is equal to negative 5. And once you figure out your two solutions of x, you're now going to substitute each of them into one of the equations to find out what your corresponding y value is. So first I'm going to substitute x is equal to -5 into, I'm going to do it into equation 2 because that's very straightforward, right? Because that would be, equation 2 is y is equal to x plus 27. So that would mean y is equal to x, which is -5 plus 27. Therefore, y is equal to 22. So the first solution, right, would be when x is -5, y is 2. And then the second solution, I will substitute x is equal to 3 into that same equation too, because it's just a very straightforward equation. So that would be y is equal to x, which is 3, plus 27, which gives me 30. So therefore, my two solutions would be, well, when x is equal to -5, y is equal to 22. And then when x is equal to 3, y is equal to 30. Right, girls? So let's go over the steps once more. You are solving a pair of simultaneous equations where one of them is a nonlinear and one of them is a linear, right? So the first equation here, equation 1, is a quadratic equation because the highest power of x here is 2. In the second equation, well, that one is a linear equation because the highest power of x is 1. So we are solving this pair of simultaneous equations, all right? Now, since both of them are equal to y, you can equate the two equations, meaning they're both equal to y, so they're equal to each other. So the first one, 2x squared plus 5x plus minus 3, sorry, that's this part here. That is going to be equal to x plus 27 because both of them are equal to y. Whenever you have a pair of equations, doesn't even have to be simultaneous. It could have been two linear. Once they're both equal to y, or if they're both equal to x, you can solve them by equating them, right? So you equate the equations, and now you end up with well, 2x squared plus 5x minus 3 is equal to x plus 27. Now, this tells me that it's a quadratic equation I am looking at. The only way to solve a quadratic equation is if it is equal to 0. That's the criteria, right? So it must be equal to 0 in order to solve the equation. So what we do is we check, we move all the terms from the other side, or we just collect all the terms on one side of the equations to make the equation, sorry, to make it all equal to 0. So here, I already had all these three terms here, and that's already looking kind of like a complete quadratic, right? So I moved x and 27 from the right-hand side to the left-hand side. If you're moving a term or you're transposing a term from one side of the equation to the other side, you change the sign, or you do the inverse of the operation. So since this was x, when I move it to the other side, it will be minus x. And since this was 27, when I move it to the other side, it becomes minus 27. And now I'm left with 0 on the right-hand side. So I now simplify my equation by grouping my like terms, right? So you have 2x squared by itself because there's no other term in x squared in that equation. So you have 2x squared. 5x, take away x gives me 4x, and then -3 or minus 3 minus 27 gives me minus 30. Another thing that I did here, which is something you should actually practice, whenever you have an equation, doesn't matter if it's a quadratic or not, if you have a common factor throughout, you can divide by that common factor to use smaller numbers. It's always easier to use smaller numbers than bigger numbers, especially if it's a quadratic where you're going to have to factorize, right? So it doesn't change the answer once you divide or multiply throughout, meaning every single term in the quadratic or equation, right? So I recognized that 2x squared, 4x, and 30 are all even numbers, and the highest common factor there is 2. So I divided throughout by 2. Each term in the equation I divided by 2. So 2x squared divided by 2 gives me x squared. 4x divided by 2 gives me 2x. 30 divided by 2 is 15, and 0 divided by 2 is 0. So now I have a simple looking quadratic. X squared plus 2x minus 15 is equal to 0. At this point, you are free to use any one of the methods of solving a quadratic equation. I chose factorization because I quickly saw that once the coefficient of x squared is 1, really you're just looking at these two numbers here. You're looking at what two factors of 15, well, negative 15, will add or subtract to give me b, and at the same time multiply to give me negative 15. So those are 5 and negative 3, because 5 times negative 3 is negative 15, and 5 take away 3 is 2. So it was easy to factorize for me, so that's why I chose it. However, you can use completing the square, you can use the quadratic formula. Once you do it correctly, you're still going to get the correct answer. So you end up with these two factors, x plus 5 by x minus 3. Both of them are equal to 0. So x plus 5 is equal to 0, or x minus 3 is equal to 0. And since x plus 5 is equal to 0, well, x has to be negative 5, all right? And then if x minus 3 is 0, then x has to be 3. But you can also just think of it algebraically as well. You move plus 5 to the other side of this equation. That would become 0 minus 5, which is negative 5. And then you move negative 3 to the other side of the equation. It will become 0 plus 3, which is 3. So now I have my two solutions of x. X is equal to negative 5, or x is equal to 3. And unlike a regular, well, not a regular, I shouldn't say regular, unlike solving a pair of simultaneous equations where you have two linear ones, if you have two linear equations, you're going to have one solution, one point of intersection. But sometimes with a linear and a non-linear, especially a linear and a quadratic, you can end up with more than one solution. You can end up with two solutions, right? So 2 points of intersection, which will be the x coordinates of those points will be negative 5 and 3. So you substitute, just like with solving a pair of two simultaneous equations where there are two linear ones, you'll substitute x into one of the equations. You're going to do that again. So I chose to substitute x is equal to negative 5 into equation 2 because working out y is equal to x plus 27, when I know what x is, it's much simpler to do an equation 2 than it is to do an equation 1. So wherever I have x in equation 2, I would replace it with negative 5. So then that would be y is equal to negative 5 plus 27. And then I did the same for when x is 3. So y is equal to 3 plus 27, which is 30. And your two solutions will be when x is equal to negative 5, and when x is equal to negative 5, y is equal to 22, and when x is equal to 3, y is equal to 30. Right, guys? How was that so far? Were you all able to follow along with me?
Yep.
Yep.
Okay, I want to show you guys, sorry?
Yes, I understand everything now.
Oh my gosh, that's music to my ear, my girl, music to my ear.
I was writing on the board earlier today, miss. I wasn't looking to right now. I just closed my eyes and went and sleep.
I want to show you all how it looks on a graph. Everybody seeing my graph on the screen?
Yes, miss.
Okay, good. So let me show you. I remember I was telling you all what it looks like on a graph, right? So let's look at it on a graph. So if you have 2x squared plus 5x minus 3. That's the first equation. And of course, it's a quadratic, right? So you see it's a quadratic curve. And then the second one is x plus 27. Well, this is that's a straight line. I had to zoom out a little bit so you can see the points of intersection. So as you can see, you have 2 points of intersections here. Oh my gosh, I keep saying points of intersections. Points of intersection, right? So you have when x here is, look, negative 5 and 22. And isn't that what we got, guys? Negative 5 and 22. So that's your first solution, right? And then your second solution is x is 3 and y is 30. So that's what it looks like graphically. Is that okay, girls? Should I download
Yes.
this and send it to you all? The graph?
Yep.
I'm gonna download it just so that you could see it, make a little sense of it. I'll send it afterwards in the notes. All right, so any pair of simultaneous equations, whether they're two linear equations or a linear and a nonlinear, they will have, you can solve it algebraically, you can solve it graphically, and graphically it's gonna, the graphs would intersect each other. Okay, so let's do another one. All right, this one isn't going to be as straightforward as the last one, but it's the same. It's the same principle, right? It's the same principle that you're using. One second. No, why am I not seeing the other whiteboard? Hold on, girls. Oh no, this is not the whiteboard I want to see. Anyway, whatever, let's see if it works. Ah, there we go. All right. Are you all seeing the old one on the screen with the equation that we just solved?
Yeah.
Okay, perfect. All right, so let's look at another one. Say we have x minus y is equal to 3, or sorry, and xy is equal to 28. All right, so this is my first equation. This is equation 1, and this is equation 2, right? Now, as you can tell, they're not equal to the same thing like the last one, right? Both of them, it's x minus y is equal to 3, and then you have xy is equal to 28. So what we're going to do here is we're going to use equation 1, right, to make x the subject of the formula here. So all I mean is to make x equal to something. So I'll keep x on my left-hand side, and I'm going to move y to the other side. So this will be x is equal to 3 plus y, right? Because here, x minus y is equal to 3. So then x would be equal to 3 plus y. And this is going to be my third equation. All right. Now that I know what x is equal to, what I'm going to do is substitute that into equation 2. So substitute 3 into equation 2. These annotations are very important. They make up part of your solution, so do not leave them out, okay? So substituting 3 into 2 means that wherever I have x in that equation 2, I'm going to replace it with 3 plus y. All right. So remember here where you have x plus xy, sorry, that literally means x times y. So when you are replacing x in this equation 2, you have to put that 3 plus y in brackets like this. So it'll be 3 plus y by y is equal to 28, right? So now I remove these brackets to simplify the equation even further. So 3 plus y times y literally means you have to multiply y by every single term within the brackets. So you'll say 3 times y will give me 3y, and then 3 times, sorry, not 3, y times y now, right, will give me y squared. So you'll have 3 plus y squared is equal to 28. Now, guys, the variable that we're working with here is y, right? So Oops, sorry, I was supposed to write 3y here. I'm sorry about that. This should have been 3y, right? 3 times y gives me 3y, and then y times y is y squared. So, as you can see, the highest power of the variable, I know before we were just saying x, but it really has to do with the variable. The highest power of y here is 2, so it makes this equation a quadratic. However, you need all the terms on one side of the equation. So I'm going to just rewrite this side, put in y squared first, as is customary to put the highest power of y first. So that'll be 3y squared plus 3y. Moving 28 to the other side, so it becomes minus 28. Or you could consider it as subtracting 28 from both sides. So this will be y squared plus 3y minus 28, and then 28 take away 28 is 0. Now the quadratic is in the form that you can either solve it by the quadratic formula, solve it by factorization, or even by completing the square. Again, because the coefficient of y squared, a in this case is 1, I know I'm only going to be looking at 3 and negative 28. And I'm asking myself, so I'm factorizing, right? I'm asking myself, what two factors of 28 will multiply to give me back minus 28 and at the same time add or subtract to give me 3? Well, those would be 7 and 4, because 7 times 4 is 28 and 7 take away 4 is 3. So my two factors will be y plus 7 and y minus 4. Has to be plus 7 and minus 4 because plus 7 times minus 4 is minus 28 and 7 take away 4 is 3. All right. And once you reach here, you would say y plus 7 is equal to 0 or y minus 4 is equal to 0. So if y plus 7 is equal to 0, y is equal to negative 7, or if y minus 4 is equal to 0, y is equal to 4. And unlike the last question where we had we solved for x first, right? We got what x was first. In this one, we got what y is first. So same principle though, same steps. You're going to have to substitute y is equal to negative 7 and y is equal to 4 into any one of the equations to find out the corresponding x coordinates. So I'm going to substitute y is equal to negative 7 into any one of the equations. I'm going to do it in equation 1 this time, right? So this would be x minus negative 7 is equal to 3 because the original equation is x minus y. So it'll be x minus negative 7. So then this would end up being x plus 7 is equal to 3. So x is equal to 3 take away 7, which makes x equal to negative 4. All right, and then I'm going to substitute y is equal to 4 into, I'm going to just do it into equation 2. Doesn't matter, right? So let's see what that would be. So that end up being xy, so that would be x times 4 is equal to 28. So x is equal to 28 divided by 4, which gives me 7. All right, so the solution would be when x is equal to negative 4, when x is equal to negative 7. What am I saying? Okay, yes, actually I could keep it like that. When x is equal to negative 4, y was equal to negative 7, right? And then when x is equal to 7, y is equal to when y is equal to 4. That's the second one. And if you were to plot these two lines on a graph, that would be a solution as well, right? You would have the 2 points of intersection as negative 4 and negative 7. and then you'll have 7 and 4 as your points of intersection. Would you girls like to see it on a graph? Or is this okay?
Yeah.
Yeah, you want to see it on a graph? Cool. Let's go look at it on the graph. Hold on. Let's share it. Right. So you should be seeing the graph anytime. It's showing on the screen, so if you're not seeing it, let me know, right? All right, so I'm just going to remove the last two equations that we had here. So this one is x minus y is equal to 3, right? Of course, that's a linear, right? That's a linear graph. And then we have xy is equal to 28. Right. So this XY graph is like we call this an asymptote, right? Um, so it's not a graph that you would see very often at all in regular math. You'll see it in ad math, but not regular math. So anyway, the points of intersection, one point is here, right, which is 7, 4, and then the other point is here, which is negative 4, 7. See? So the solution stands. It doesn't matter, girls, how you work it out. It's going to be the same algebraically as it is on a graph. And I'm saving it to send to you all afterwards to add to your notes. All right, let me just pause the recording for a second. Right, guys, so I need you all to pay a little closer attention to this one because the substitution is a little more than what we've looked at before, right? So we have this first equation, your linear, which is 4x plus y is equal to 11, and that's equation 1. And then you have 3x squared plus y squared is 21. That is equation 2. All right. So again, you have a quadratic and you have, well, not a quadratic, sorry. You have a linear, which is equation 1, and you have a nonlinear, which is equation 2. Now for this, most times, guys, it's gonna either be like where you equate the two equations or you're gonna have to do some kind of substitution, right? The first example, this one, let's just go back and look at it quickly. This one was where you equated the equations because they were both equal to y. The second one, we rearranged one of the equations to get x is equal to something, and then we substituted that into the other equation. Likewise, we could have made y the subject to it. We could have done y is equal to x take away 3, and you would have still ended up with the same answer, right? So most times with equations, with simultaneous equations where you have like a linear and a nonlinear, it's either going to be a substitution or some kind of equating of the two equations, right? So in order to substitute into the other equation, though, it must be where x or y or whatever the variable is equal to something. So x or y, the coefficient is 1 and it's being equal to something else. So you substitute that into the other one, right? So the easiest substitution to do here is by using equation 1, right? So using equation 1 and making y the subject. So I'll keep y on that side, and that would give me y is equal to 11 take away 4x. And that is my third equation. So now that I have y is equal to that, wherever I have y in the second equation, I could replace it with 11 minus 4x, right? So I'm going to substitute equation 3 into equation 2. You must substitute it into the other equation, all right? So that would remain as 3x squared. And wherever I have y, I am replacing that with 11 minus 4x. Now notice that this is y squared. So this would really be 11 minus 4x all to be squared, right? That is equal to 21. And now we have to simplify this equation. Now, 3x squared remains the same. because we're not doing anything there as yet. However, 11 minus 4x squared is not 121 minus 16x. It's actually 11 minus 4x squared literally means 11 minus 4x times 11 minus 4x. So please be careful with that. That is a mistake that lots of students make, right? They just squared what's inside the brackets, but that is not so. It's y squared, which means whatever y is, you have to multiply it by itself. So if y is equal to 11 minus 4x, if all of that is to be squared, it means you're going to multiply 11 minus 4x by 11 minus 4x. Right? So let's expand that and see what we get. So this will be 3x squared. 11 times 11 is 121. 11 times minus 4x will be minus 44x. Minus 4x times 11 is minus 44x. And then minus 4x times minus 4x will be plus 16x squared. All of that is equal to 21. All right, so now we simplify this even further. This would be, well, 3x squared. I'm going to group my like terms. So I'm going to put plus 16x squared next to the 3x squared, since they are both terms in x squared. And then I have minus 44x and minus 44x. So that would give me minus 88x. I have plus 121. And I'm going to move this 21 to the left-hand side to become minus 21 to make all of this equal to 0. Because if you didn't realize this yet, this is a quadratic. And in order to solve a quadratic, it has to be equal to 0. So 3x squared plus 16x squared will actually give me 19x squared. And then, well, it's 88x. 121 take away 21 is 100. All of that is equal to 0, right? So, girls, unlike the other equations, like questions like question 2 and question 1, where we were able to use factorization, I have no clue what to do to factorize this one. Because to factorize this, not that I have no clue, but it'll be very complicated to factorize if it can even be factorized. Because here, the coefficient of x squared is 19. So you'll have to say 19 times 100 is 1900. And then you have to think about which two factors of 1900 will add or subtract to give you 88, and at the same time multiply to give you 100, and I mean to give you 1900. So that is too tedious to think about. So I am going to use the quadratic formula to solve this equation, right? So let's identify A, B, and C. So if you recall, A here would be the coefficient of x squared, which is 19. B is the coefficient of x, which is negative 88. And C is 100. Just to be clear, the reason I'm doing this question is because this was one of the examples that you all got in school, right? But for CSEC, you're not going to get something like this, right? It'll be much simpler. But anyway, let's solve the quadratic using the quadratic formula to recall as well. And also in CSEC, you are given the quadratic formula. So have no fear if you can't remember what it is offhand, right? So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And of course, I showed you all how to use the quadratic the online quadratic calculator as well, if you're having trouble with this. Because I love that the one that we use, I think it's from Calculator Soup, I can't remember, but that one gives you the full solution, so you see all the substitutions and stuff, right? But let's do it together anyway. So x will be equal to, well, minus b. Now b is negative 88, so that will be minus 88. plus or minus the square root of b squared, which is negative 88 squared, minus 4 times a, which is 19, times c, which is 100, all over 2 times a, which is 2 by 19, right? Now let's simplify. So this negative 88 will just be positive 88. Plus or minus the square root of 88 squared is 7,744, right? So 7,744, take away 4 times 19 times 100, which is 7,600, all divided by 2 times 19, which is 38. So then this would be x is equal to 88 plus or minus the root of 144, because 7,744 take away 7,600 is 144. All of that divided by 38. So as you can see, the square root of 144 is 12. So this would actually be 88 plus or minus 12. So you'll have x is equal to 88 plus 12 divided by 38, or 88 minus 12 divided by 38. So let's see what that would give me. 88 plus 12 is 100 over 38, which can be reduced, right, to be 50 over 19, or 88 minus 12, which is 76 over 38. And again, that can reduce by 2. So 76 over 38 is, 78 over to the 8 is actually 2. 76 divided by 2 is to the 8. So the solution would be x is 50 over 19, or 2. And you can write 50 over 19 as a decimal, by the way. That will be 2.63, right? So it doesn't matter. You could leave it as a fraction, or you could write it as a decimal. Any method will be fine, right? So now that we know what x is and what the two solutions of x is, we can find out what y is. So let's substitute x is equal to 50 over 19, right? So substitute, oops, why did I write it so horribly? Substitute x is 50 over 19 into any one of the equations. I am going to put it in equation 1, that's the non-linear one, which was that one was 4x plus y is equal to 11. So it'll be 4 times 50 over 19 plus y is equal to 11. So on your calculator, you'll check what is 4 times 50 over 19, which is what is that? That would be 200 over 19. Because 4 times 50 is 200. Plus y is equal to 11. So then y is equal to 11. Take away that. Yeah, so guys, you're not going to get something like this for CSEC with these weird numbers. Most times, CSEC gives you nice whole numbers to work with. Right, so 11 take away 200 over 19 is 9 over 19. And then the other one was when x is 2. So substitute x is equal to 2 into, I'm going to do it in that same equation 1. So that would be 4 times 2 plus y is equal to 11. So 8 plus y is equal to 11. Therefore, y is equal to 11. Take away 8, which means y is equal to 3. So your two solutions here when x is equal to 50 over 19. And like I said, you can write it as a decimal if you wish. Y is equal to 9 over 19, right? As a decimal, 9 over 19 is 0.472 to three significant figures. And 50 over 19 is 2.632 to three decimal places, right? So when x, so this is your solution. Now I know this looks a little complicated, but it's only because of the fractions. No other reason. It looks complicated because it's literally the same steps, right? Then when x is 2, y is equal to 3. And guys, let's look at it on a graph. Let's look at it on the graph and see. So I'm gonna remove these old stuff, the old info from the previous graphs. This would be, the first one is 4x plus y is equal to 11, right? So that's the linear one. And then you have 3x squared plus y squared is equal to 21. Right? So this is actually, it's not a curve. As you can see, it's a circle. All right. So the two solutions that we got when we worked it out, it was 2, 3, if you'll remember, right? So look, that's one solution here. It's 2, 3, right? And then the other one was something with 2 points. Look at here, 2.63158 and 0.47. So this is the whatever over 19, 2 and 12 over 19, and 9 over 19, right? But this is just the solutions as decimals. So this equation, 3x squared plus y squared is 21, is actually the equation of a circle, right? So this is when you're solving a pair of simultaneous equations where one is a linear and one is a circle. And like I told you, you're not going to have to learn a circle, the graph of a circle. You don't need to know anything about that in regular maths. Add maths, yes, but not regular maths. The recording. Right. So when you have two equations like this, where you have y is equal to 2x squared plus 1, and then another one as y is equal to something, because they're both equal to the same thing, meaning that 2x plus 2x squared plus 1 and 7x plus 5 are both equal to y, then it means that they're both equal to each other. So what we can do is we can equate 1 and 2, meaning that we literally say that 2x squared plus 1 is equal to 7x plus 5, right? Because they're both equal to y. Cool, is that okay so far?
Yeah.
Right? So it's if they're both equal to y, it means they're both equal to the same thing, right? So the next thing, we equated them. We said 2x squared plus 1 is equal to 7x plus 5, right? And now, because this is a quadratic, the reason it's a quadratic is because you have this term in x squared, right? That's the highest power of x in the equation. This is a quadratic, and in order to solve a quadratic, it has to be equal to 0. So that means you need to bring all the terms on one side of the equation, making the other side equal to 0. So I'm going to keep 2x squared on this side, and I'm keeping 1 on this side as well, and I'm going to transpose 7x from this side to the other side. Now this is plus 7x. So when I bring it to this side of the equation, it will be minus 7x. And when I move plus 5 to the left side of the equation, it would become minus 5. And now all that's left on the right-hand side is 0, right? You can also think of it as though you're subtracting 7x from the equation from both sides. So you'll end up with minus 7x on this side. And well, 7x take away 7x will be 0. And then you subtract 5 from this side and the other side, so you get minus 5. However you want to look at it, whether transposition or balancing, it's fine. But you need all your terms on one side of the equation and the other side being equal to 0 because it's a quadratic. And now what we're going to do, remember we want the quadratic to take the standard form. That is ax squared plus bx plus c, right? So I'm going to simplify this side of the equation now by grouping my like terms and simplifying. So I have no other term in x squared other than 2x squared. So that will just remain as 2x squared. And I have minus 7x by itself as well. And now I have plus 1 take away 5. So plus 1 take away 5 is minus 4. And all of that is equal to 0, right? Now, at this point, you can either solve the quadratic by using the quadratic formula, by factorizing, or even by completing the square, right? Any one of those methods will give you the solution. I am going to factorize. Now, the steps in factorizing a quadratic is you identify A, B, and C. So A here is 2, B is negative 7, and C is negative 4. So AC here would be AC would end up being 2 times negative 4, which is negative 8, right? And B is negative 7. So you ask yourself, and I don't know if you remember this clearly, Zafi, but you ask yourself which two factors of negative 8 will multiply to give you negative 8 and at the same time add or subtract to give you negative 7. Well, there'll be 1 take away 8 because 1 take away 8 will give you negative 7. So it satisfies this condition. And then 1 times negative 8 will give you negative 8. So it also satisfies the condition of multiplying to give you back AC. So now we're going to rewrite the quadratic, replacing minus 7x with x minus 8x. So this equation will become 2x squared take away x plus x take away 8x minus 4 is equal to 0, right? And now you factorize by grouping. So you factorize the first two terms and then the second two terms. So you'll say the common factor between 2x squared and x is x. So x into 2x squared is 2x. And then x into x is 1. You bring down this minus sign. The common factor here is 4 between 8x and 4, right? So that will be on the outside. You say 4 could go into 8x 2x times, and then minus 4 into minus 4 is plus 1. So your factors here, you see you have the same thing, so you have your repeated factor. So that would end up being 2x plus 1 into x minus 4. So your two solutions here, you'll have 2x plus 1 is equal to 0, or x minus 4 is equal to 0. And if you have 2x plus 1 is equal to 0, that means 2x will be equal to 0 minus 1, which is negative 1, and then x is negative 1 over 2. And if you have x minus 4 is equal to 0, then x will be 0 plus 4, which is 4. Now you have your two solutions of x, so you substitute x is equal to half into one of the equations. I am going to put it in equation 2. So wherever I have x in equation 2, I'm replacing it with a half. So this will end up being 7 by a half. Well, sorry, y is equal to 7 by a half plus 5. So 7 times a half would be 7 over 2 plus 5, which will be 12 over 2. 7 over 2 plus 5, which is not 12 over 2. What am I saying? Sorry. 7 over 2 plus 5 over 2 will be 17 over 2, which is really 8.5. Right? And then you substitute x is equal to 4 into equation 2 as well. So that would mean y is equal to 7 times 4 plus 5. So y is equal to 7 times 4 is 28 plus 5 is 33. So your solutions here would be, your solution would be when x is a half, y is 8.5. And when x is 4, y is 33. Anybody got it? I have a mistake. If you got 4 and 33, but then you got negative a half, 8.5 is not correct. I'm so sorry. I did not realize x is negative a half. So this should be 7 times negative a half, which would be negative 7 over 2, which would then give me negative 7 over 2 plus 5 is actually 1.5. I just peeped that mistake there. Oopsie. Sorry, girls. Well, now that I fixed it, anybody got it? Negative a half and 1.5 as one of the solutions, or you all still didn't get that? Yes, no, maybe. Um, And I do want to say, though, I want to say thank you for trying, all of you, because even if you all aren't doing it in school, you are all very willing, and I appreciate that effort. You will reach far, right? So again, they're both equal to y, so you equate the equations, right? So you'll say 1 is equal to 2, meaning that x squared plus 4x minus 3 is equal to 5x plus 3. So then this would be, you want to group all your terms on one side so that it's equal, the equation is equal to 0. So you'll have x squared plus 4x minus 3 minus 5x minus 3 is equal to 0. Then this would be x squared 4 minus 5 is minus x. So x squared minus x. Minus 3 minus 3 is minus 6. All of that is equal to 0. Good. And I think this could factorize. Let's see. You need 1 and you have minus 6. So it could be minus 3 plus 2. Minus 3 plus 2 will give me minus 1, and minus 3 times 2 will give me minus 6. So factoring will give me x plus 2 by x minus 3 is equal to 0. That means that x plus 2 is equal to 0, or x minus 3 is equal to 0. So then x would be 0 minus 2, which is negative 2, or x would be 0 plus 3, which is 3. Now that we have what x is, we can substitute. This one was much simpler than the other factorizing because the coefficient of x squared was 1. So we substitute x is equal to negative 2. I'm going to do it in equation 2 since that's the linear equation. It's easier to substitute there. So you'll get y is equal to 5 times negative 2 plus 3, which means that y is equal to negative 10 plus 3. That gives me negative 7. And then I'm going to substitute x is equal to 3 into equation 2 as well. So that would be y is equal to 5 times 3 plus 3, which means y is equal to 15 plus 3. Y is 18. So my solution here is when my solution is when x is equal to -2, y is equal to -7. And then when x is 3, y is equal to 18. And I hope I didn't make any mistakes. I think it's good there. All right. Girls, anybody got it? Well, Janaya, I saw that you got it because I saw that you sent it to me. Excellent work. Anybody else? Anybody else was able to manage this one? Let me see. I'm gonna stop the recording here. It's 2 hours. Wow.